And it's that outside in. You've got to be led by the market. People say this all the time, but if you really stop and think about what it means, like you got to look at your environment. Your environment dictates 95% of what happens to you. The other 5% is, your skills, everything else. Actually, you've got to be listening to that.
Welcome to the Lab to Market Leadership Podcast. Too many advanced science and engineering companies fail to deliver their innovations from the lab to the market. We are on a mission to change that. My name is Chris Reichhelm, and I'm the founder and CEO of Deep Tech Leaders. Each week, we speak with some of the world's leading entrepreneurs, investors, corporates, and policymakers about what it takes to succeed on the lab to market journey. Join us. For those of you out there building a containerized solution of some kind, you could be in climate tech, you could be in industrial tech, but you're building a heavily engineered, multidisciplinary solution to do something significant. It could be waste to energy, it could be plastic recycling, it could be whatever. You need to listen to today's podcast. I'm speaking to the CTO, co-founder, and engineering lead of a company called Impact Recycling. Impact Recycling spun out of its parent company, Impact Solutions, in 2017. In the space of the last 7 years, these guys have taken their platform from very early research, maybe a small prototype, through to true TRL9, MRL10 in the market, and the winning of many multi-million pound contracts. 5 million, 14 million, 58 million pounds, okay? From start to today, 7 years. In my experience, that's a lab to market journey that is worth hearing more about. We're speaking to James Finlayson, who is the CTO, co-founder, and engineering lead. I want to find out from James, or Jamie as he's known, how he's gone about that, how he built the team, how they managed to move through those different milestones and phases as quickly as they did, how they were able to engage their customers along the way. This is going to be an enlightening episode. I know it. I hope you enjoy. Let's get into it. James Finlayson, thank you so much for joining me today.
No problem. Thank you for having me.
You and the Impact Recycling team have done what I feel is very unique in a fairly short space of time. And remember, of course, we're talking about real physical tech here. We're building containerized solutions, big units, require lots of engineering, multidisciplinary, of course. But these things can take a very long time to build. They can take a very long time to get validation for, moving through the different TRLs and MRLs and so on. And of course, they can take a long time to commercialize. You guys, given some of the contracts that you've put together in a fairly short space of time, have managed to, I'm not going to say make it look easy, because it's not easy, but you've done what I think many would love to do, but haven't been able to. So I want to get into this a little bit with you and kind of understand, in as much as we can, how you've managed to do that. And where I would love to start is, I guess, by understanding a little bit your background, where you come from, what that early experience, because obviously this is going to be about you and the journey you've been on, and of course the journey the company's been on. But help me understand, just to set the scene a little bit, when you came into Impact Solutions, what was the nature of the experience that you have had?
Okay, yeah. So I was brought up on a farm, I guess. So I've got a lot of hands-on experience. And actually, prior to university, spent a lot of time working offshore, a couple of years working offshore oil and gas. You could do that out of Scotland if you had good grades. And then laterally, some time in Norway in a paint factory, but realized that, with the sunset industry in the northeast of Scotland, perhaps I needed a degree to formalize what I was doing. So went to Edinburgh University, did chemical engineering. And at that point had a change in heart. They really hammered home the fact that we've got alternative ways of making energy, but not alternative ways of making industrial precursors, which is something useful, that you can turn oil into. And to be honest, the experience of earning money prior to going to university perhaps jaded my university experience somewhat. I just couldn't wait to get out of the place, get back to earning, getting my hands on things and doing some real commercial work. So the day of my last maths exam, I must have spammed 100 companies looking for a job, and Impact Solutions returned my email straight away. Had a phone call with the managing director there and was into work the next day. So I hadn't graduated yet. It was one day after my exams, and I was working at Impact Solutions. So they were a polymer test company, looking at all different ways of testing and developing virgin polymer. And I was perhaps overqualified for the role that I'd been given. It kind of made sense why they wanted me, and it made sense that I just wanted to get my hands moving. And the deal was I could look at some business development opportunities if I could get through all my work in sub 40 hours a week.
Okay.
Yeah, so that's how I came in. Yeah.
But wow, so before you had even graduated, you'd sent out 100 emails to companies determined to get a job.
I can't tell you how fed up I was of academia. As much as I had good grades and did very well at school and everything like that, it just wasn't for me. It felt like a bit of stasis. It felt like standing perfectly still whilst all the opportunities were moving by.
Yeah.
Yeah. So I was delighted just to get my hands moving again.
Yeah. And so you're in Impact Solutions. What serves as the catalyst for the birth of Impact Recycling?
So outside of the sort of day job, I got involved in a project called BOSS, and BOSS stands for Baffled Oscillation Separation System. It's a technology at the core of what Impact Recycling do. The project was, I suppose, in its infancy. Some minor attempts were made to sort of scale it up, but I would say that it needed a much broader scale up than had happened. And I came into the project and started to show that, well, first of all, that I think I understood how it worked a bit differently to the scientists originally working on the project. And together with a team at Impact, convinced the board, Impact Solutions, that is, convinced the board at the time that we need to scale it up a different way and completely change what we're doing.
Where was the company? Where was this technology? Sorry, let me just jump in here real quick. Where was the technology at that point in terms of TRL?
I'd say 3 or 4. Yeah. So it wasn't TRL 0, but we might as well have gone back to 1 or 2 just to reappraise some of the assumptions. So inherited, I suppose, some background information, some background IP, and really looked at how we could apply it, how we could scale it up. And I suppose managed to completely change the philosophy around how the machine worked. We came in and people were trying to figure out in the minute detail how the physics worked before they scaled up. And really my approach is very different. My approach is to, let's look at established scale-up maths. Things for like distillation columns, separation systems that are proven time and time again, empirical models, and see which one we could, slap on top of what we're trying to do. And the way BOSS actually works, it's a series of plates, they oscillate up and down. So you have a series of separation stages. It's a separation system. And actually it plugs directly into distillation maths perfectly. In fact, the only term within distillation maths that you need to change is relative volatility. And of course, we could fudge that and make it relative buoyancy, which is one of the mechanisms by which BOSS works. So rather than understand how it worked, all we needed to do is understand what the stage efficiency was. And then with that, we could scale it up. The maths would tell us how many stages above and below a feed-in point we needed to achieve purity on the top product and the bottom product. And then we scaled it up like that. And actually, in hindsight, that was the smartest thing I've ever done, because the physics around how BOSS is separating is really, really complicated. In fact, trying to model it with computational fluid dynamics is very difficult. You need 3 different solvers, essentially. And as far as I'm aware, nobody's really come up with a solver that would be able to do everything that's actually happening in the machine. Instead, there seem to be sort of broad physical principles that make the separation happen, but that doesn't matter because we have stage efficiency. And of course, we can then just get the purity we need for the throughput without actually having to worry about new physics in the middle.
And so you applied a different perspective, looked outside, seemed to make it relate to what was already out there in terms of other platforms and other systems.
Exactly. Stand on shoulders of giants. Someone said that once.
Yeah.
And that's what you got to do. Like, there's hundreds of years of engineers and mathematicians have looked at distillation and brewing and all these industries where there are very good empirical models for how you scale up things that actually at the time they didn't fully understand either. Like, if you look back at the history of industrial engineering, quite often it's getting results before the chemistry or the physics is properly understood. They might think they understand it, but everything actually changes over the next 20 years because the process actually reveals X, Y, and Z that nobody thought about. So really, whilst I was at university and going to Edinburgh was particularly beneficial, you get to see a lot of that history, like first of a kind industrialists. And actually, I really admire them because it's a combination of enough technical know-how to know that a lot of things aren't important, but to focus on the few things that are, but then also tying it to the real commercials, which kind of underpins everything. And that was the second thing I think, any startup or anything I do again, I'm going to continue to do is to think outside in. So not just in terms of the technical, using pre-established models to, I suppose, crudely scale up something and understand it more, but also bring the market into everything we do. So we knew, because we were a polymer test lab, that separation of polyolefins was really, really important and was going to be, I suppose, a gap in the IP landscape if recycling was ever going to happen at the scale it was going to. So we had that commercial awareness. And as a test lab, we also knew that you probably needed 95% purity. Some people were saying 98, some people were saying 90. We thought 95, and we had some tests to show that. So immediately I've got boundary conditions for what is an engineering scale-up. It needs to be 95% purity, meaningful tonnage for the prices is about 6,000, 7,000 tons per year. And we've got a stage efficiency. I didn't actually need anything else. It was in my textbook called Fenksky Underwood Gilland method for distillation scale-ups. Yeah.
Wow. What kind of resources did you have in order to figure this out in these early days?
Time. I had my own time. Yeah. And a really, really, really great team and Impact Solutions as well. So their journey is very interesting as well. When I joined, it was maybe 7 or 8 people. By the time Impact Recycling was fully spun out, it's maybe 25, and now I think they're up to 40, 50 people, and they're all doing early stage technology development. But at the time, what we had was polymer technicians and some really, really good managers. So a very strong commercial manager, some good managers out of BP as well, who applied really strict rigor to everything that we were doing. But it was the right blend of, I suppose, structure, but then also freedom. Like, it was also a little bit chaotic because it was a small team. You could pivot very quickly, and actually that's what it needed. We needed to fail fast in certain things, and I suppose have the spirit to give it a go. That was the main thing. Now, grant funding was hugely instrumental as a company whose core business was testing polymers for certain applications, be it establishing, how long a pipe can stay in the ground at a given pressure before it bursts, or what the environmental stress crack resistance of a particular grade of polyethylene is for, I don't know, shampoo bottles or something. That was their core business. The kind of cash that the BOSS project was starting to ask for was just not manageable. So grant funding was instrumental. So a big part of what I was doing at the start was helping and working with my commercial director, Stephen, to essentially frame grants, find, pools of money that we could draw down, ideally ones that were 80 or 100% funded, and scale it up. And we managed to actually scale it up to the point where we had a prototype, which was 1 ton per hour. And the business model at the time was to sell units, was to sell BOSS as a machine and plug it into a waste manager's facility. And I don't know how we managed to do that, if I'm being honest, but we did. We sold 4 machines, 1 down to London, 1 over to Northern Ireland, 1 to Spain, and then another for a site in Scotland. And Yeah, that was a huge part of the adventure then, was to go off to these sites, build and fit it myself with our engineering partner. I say engineering partner, it was a very small family, mom and
Right.
pop shop type thing. That's what
Right.
you need as well
Yep.
at that scale. You needed that dynamism. So we went over, fitted these machines, commissioned them, got them to the required purities, everything like that. But I was coming back from these sites thinking, there's a huge knowledge gap here. This isn't the right outfit to run what essentially was a piece of manufacturing equipment. The values in waste management are very different to the values in manufacturing.
Yeah.
And if you think about what recycling is trying to do, it's trying to join the value chains together. You're trying to take waste management and plug it into manufacturing. Well, there's a discrepancy in values there. Quality, stop if the quality is not right in manufacturing, never stop in waste management. It's about moving it along. But there's also a scale discrepancy. And I mean, the scale discrepancy is the one that is really hard. And we'll get onto that when we talk about sales. But in waste management, you're talking millions of tons per year. Large manufacturing in polymers, maybe be 40,000, with the average maybe being more like 6. So yeah, very, very different. And we were selling to the waste managers who are just, obviously trying to push everything through it.
Now,
so
let me ask a question. When you started, when you sold your first 4 units, were these real market ready units, or were they, in terms of TRL, or were they, were these like, first of a kinds?
First of a kinds, yeah. So, I mean, okay, so 1 came first, then 2, then 3, then 4. They were sequential. It wasn't a job lot. And in my memory, it's all sort of lumped together because they were quite quick, actually, because we're just at the right time that people were starting to take an interest in plastic recycling. So yeah, the very first one went and installed. First of all, it was evaluating the changes that I proposed, and they seemed to work quite well. The changes we could, moved off of running batch to continuous, things like that. So, the flow assurance was there. We were getting a ton an hour. The quality was good in terms of the density, everything like that. But it hadn't been, other than running a few hundred kilos at our manufacturer site, it hadn't been run in earnest. Like, these were first of a kind for each of these operators. And it definitely didn't say that in our sales literature, at all. But as it happened, going to these sites and commissioning these machines and, saying to people, you've got first of a kind, and they're all very excited about the process. I learned so much about the upstream process, so much about the downstream process, and got visibility that the sales, we were making this product that didn't actually have a market. Everybody assumed that if you could get to 95% purity, that people would bite your hand off for the material. And that's just wrong. Like, manufacturers changing the raw material is a huge change. If you're thinking about your ultimate customer here at the end of the chain. Yeah. And I mean, the manufacturers that I'm talking about are often third-party molders who mold on behalf of a brand. So if you can think about the decision gates that you have to go through to get somebody to change their material, often for, same raw material costs, but with different KPIs. So much lower uptime. There's a whole change management piece on that. So I was coming back from these sites.
And had those things not been properly figured in your analysis earlier on, you weren't thinking of the offtake. You weren't thinking of what the ultimate clients would want from the material that your system would produce.
We were thinking about it as a team, but because nobody had ever done it, we didn't know what we didn't know. Everything was very theoretical. We'd gone out to sites and said, if we could supply this, would you buy it? And of course they said yes. But, one of the lessons is, until you've actually got a meaningful volume and you supply it into somebody and then they reorder it, nobody really knows whether it actually works for them. That was a really sharp lesson.
Okay.
And of course, at that time, I was so focused on the remit. Just make this 95% pure at a ton per hour rate, and have a unit that is you can sell for under 300,000 euros. Away you go. So I was very much focused on that. And it was only as I'd achieved all that and thinking, all right, what else needs to happen here? I started to poke my head out of my little sandbox and look around and realize that there was so much unknown in terms of commercials, but also technical.
Yeah.
Because one of the key stories, I'm painting a very vague picture on the commercials at that point in time, but also like it turned out that everything you do upstream of the boss process is hugely important to how the process works. Without getting into too much detail, it separates on a combination of apparent density and drag coefficient, which means the size distribution profile of your material does actually matter, which means that not only the machine you select to reduce the size of your material is important, but also your operational procedures and maintenance procedures. So we ended up with our customers, I was spending as much time on their sites helping to optimize their upstream process as I was, doing anything on Boss. Like Boss was working away. It still needed more work, but my time was being spent there. And it's at that point we're sort of thinking, oh, we should do a demonstration facility. Like we can do this better than these guys.
Did you guys build a demo unit, a demo facility?
We spent 3 months maybe discussing amongst ourselves whether that's something that Impact should even do. So Impact Solutions. So it seemed to be sucking all the time and resources and money out of what was the core business. And it was. And actually, history proved those doubters to be totally right. The amount of money we needed to get Impact going was just, I don't think we're at the end of it. Put it that way.
Yeah.
So members of the team recognized that and suggested that we needed to spin out Impact Recycling. Now, thankfully, Impact Recycling had been founded before to make use of the grants or to avail of the grants, so that we were bringing grants into a proper legal entity and everything like that. And so it was very shrewd and forward-thinking actions on the commercial team's part. So we had a vehicle. It was Impact Recycling. It had everything. The patent had been licensed from Impact Solutions across. And I suppose the remit was go find someone who'll put some money and we'll build a demonstration facility somewhere. And that's when we hit the road and went to trade shows. Just walking around trying to talk to people. And amazingly found an Irish gentleman, David Walsh, who's, we've worked together a long time now and is our CEO currently, who saw the benefit of what Boss was doing. He was at the time looking at some other projects which had some issues with commingled plastics and didn't know how to, I suppose, get the value out of them from that process. Showed him what we were doing, which at the time was quite a limited version of what we actually did, which was just Boss buying in third-party regrind, which is granulate, so pre-shredded material essentially. Just Boss drying and bagging. The idea being that we would buy in something for 150 and sell it for 500. And he quite rightly pointed out, well, you've spent all this time learning that your current customers can't prepare it correctly. So why do you think you're going to be able to get stuff out the market that's prepared correctly? We should do the whole thing end to end. We should take in raw material, shred it, wash it, granulate it, put it through Boss, dry it, bag it, and sell it just as a flake. And with the best part of 400, 500,000 pounds, we built an entirely second-hand facility in Newcastle with a new Boss machine at the end of it. And Chris, it was a disaster. We'd spent...
Oh, really?
Yeah. We'd spent this whole time telling our customers that they didn't know how to shred and wash properly. And it turned out neither do we. Okay, it turns out that, we had all secondhand equipment, so you've got issues with uptime and repeatability and breakdowns and all of that. But actually, do you know what? It was the best year and a half in terms of the engineering know-how gleaned, because, every single night was in the machines, fixing them, modifying them, tweaking them, holding it together so that when we tried to operate the next day with our staff, we'd at least get a good run at it and learn something more. But yeah, living in Newcastle under a desk for a wee while, that was a necessary part. Oh, the other thing I should say is it turned out we knew nothing about operations, like how to manage a factory.
Had anyone in the team managed a factory before?
Yeah, so one of the things David Walsh did was, his background's finance, by the way, hedge funds and just sustainable finance. And he brought in another gentleman, Jeff Bailey, also from Southern Ireland, and they sort of went halves on the seed investment, I suppose. And Jeff came in as CFO, David was CEO, and I was in as the engineer, the boss guy. So Jeff had run successful waste management companies before. So I suppose we felt there was enough know-how there. But it turned out, knowing what I know now, it is hard enough to execute an operation with established technologies trying to sell into a known market. What we're trying to do is take new technologies with an unproven process. So the process is unproven. The technologies within it's unproven, really, with feedstock that everybody says you can't use, and then make a product in a new market with undefined customers.
What could go wrong?
Everything. Everything. I mean, a lot went right, but a lot went wrong. I mean, there's a whole other big problem I'm about to get to as well. So I'll skip over a few things, but essentially running that line, and we were separating our polypropylene, polyethylene, and breakdowns all the time and getting in to fix it, everything like that. We started to be able to sell our polypropylene to people who make plastic pellets. They're called compounders. So they maybe sit upstream of the converters who make buckets and bins and things like that. We could sell our polypropylene. That was fine. We couldn't sell our polyethylene. Polyethylene, it was pure by species. It was a very discrete density band. But for those who know plastics, in extrusion polyethylene and injection polyethylene may as well be different species. Because manufacturing in polymer, the polymer is actually tuned to the manufacturing process, not the other way around. Like they tune the material to the manufacturing process. So we had mined at scale, essentially, or extracted at scale, pure polyethylene, which was a random distribution of molecular weights, random distribution of rheologies, which is basically how runny it is when it's molten, random distribution of colors, everything like that. So when we went to sell into what I now know is a highly segmented market, we didn't have anything that fitted any segment. We had this very general, broad polymer, and it was curtains for the business. As a business, we had no money. We've never really had a lot of money. We were selling polypropylene, but we were storing polyethylene. And we got to the point where we had maybe 300, 400 tons of polyethylene in stock, which was valued on the balance sheet at 500, 600 pounds per ton. Yeah. About that time, wow, IW Capital came in. So we held it together long enough to show that BOSS was working, and that was a key thing. And IW Capital, who are currently our biggest shareholder, they're an EIS fund. They invested in us. They gave us 1.8 million pounds. And I tell you, after fixing machines myself and not having an operations manager, when we finally got money, the first thing we did was hire a very good operations manager. David Mahoney was a very strong man manager. And the second thing we did is we knew exactly what kind of shredder to buy. We knew exactly what kind of sink float to buy. And they were all slightly custom. So we'd be saying to the suppliers, saying, yeah, we want this shredder, but I don't want that, I want this. And they're asking why. And we're sort of like, don't you worry. But really it's because I'd been in the machines that much that I knew exactly what to do. So we got that investment in and, basically built a new line now. So we could do the tonnage, but we still had the polyethylene sales problem that managed to sort of bubble away. Nobody really talking about it too much. David and I, well, David mostly actually, going to every trade show trying to find a solution for this. And it's an industry-wide problem. For anybody who's trying to recycle at a meaningful scale, unless you're excluding all of the feedstock and just picking things with a known rheology, you're going to have this problem. And amazingly, and this was at the start of COVID as well, I should point out. So COVID then hit. And amazingly, David found a company in Belgium with a very smart woman, her scientist, who had developed an additive for virgin processing, virgin polymer processing that helped with flow lines and changing the rheology essentially without changing the molecular structure. So it's sort of like a passive additive. I'd say the state of art in polymer processing is to get in there and either create bonds or break bonds with chemical agents, be it, peroxides or something like that. But when you do that, you do change the mechanical properties. So to make polypropylene runnier, people do add peroxide. That makes it very runny. Her solution didn't involve any of that. It's actually a technique ported over from food processing, where you need shear thickening and shear thinning additives that are both food grade, but also passive in the rest of the process. So we spent most of COVID developing that around Boss material. And I mean, it works. It's a really good additive. And actually now what we have is a really unique IP offering, whereby at the feedstock side, we take the pile that's left behind after everybody says, right, we can't do anything more with that. Let's send that to incineration or landfill. We take that material, we put it through Boss, we sort it into purified polypropylene, polyethylene. And then with the additive, we can tailor it to very specific melt flow rates now. So our polypropylene, we can, let's say we got 100 tons of that off of Boss, we could sell 50 tons of that to an injection molder and then 50 tons of that to an extrusion process, which one's very stiff when it's molten, one's very runny. And this completely changed the game, because now we could sell into very specific segments. And it's a huge part of what Impact do now.
How long did it take you guys to figure this out and to come up with this eventual solution?
Yeah, so that would have been 2020, halfway through 2020. So we started the factory in 2016. It's when that original seed funding came in and sort of holding it together for a year and a half. So, thinking back to what you said at the top of this conversation about the overall story and how we got there, a really, really important thing is to keep moving and not die. Like, you can't stay on your current stepping stone when you're trying to do this stuff. If we stayed back and just we're trying to make Boss for as a toll service, essentially sell it over to waste managers, it wouldn't have worked. If we just built a factory that just had Boss, it wouldn't have worked. If we built the factory just to shred and Boss, it wouldn't have worked. Now we have to incorporate pelletization. We've got a thermal process where we take the output of Boss, blend it with our additive, make a pellet. So we're going up that chain a bit more. And we've had to do that because the space has been moving around us. The commercial assumptions have changed every 6 months, really.
That's so funny.
When I think back to it, it's a series of stepping stones that have meant that we haven't died. And if we stood still, we would have died. And the stepping stones are scary ones, because we're often leaping and then backfilling the progress with investment. So, we're leaping off of cash flow and then backfilling the balance sheet.
And so even if you're not sure of the steps you're taking, even if you don't know that they're going to lead to the right place, the main thing is that you keep moving.
You keep moving,
hope that somehow you can tie it all together.
Yeah, and it's that outside in. You've got to be led by the market. People say this all the time, but if you really stop and think about what it means, like, you got to look at your environment. Your environment dictates 95% of what happens to you. The other 5% is, your skills, everything else. Actually, you've got to be listening to that. And everybody was telling us what we were doing was amazing and great. So we knew we were doing something right, just nobody would pay us for, we weren't seeing the commercial benefits of it yet.
So were they BSing you?
No, because I'd say there's different stakeholders. So sustainable funds loved what we were doing, but we were not making money, so we were uninvestable. So that went away. The feedstock suppliers absolutely loved what we were doing, but we were so tiny compared to what waste management volumes run at. And the manufacturers said they liked what they were doing, but as an industry hadn't really, I'm really painting with a broad brush here, but hadn't really thought about changing everything to deal with PCR. It's supply chain, it's testing, it's all their quality, it's their UN approvals, it's absolutely everything. And really the stepping stones were led by what are we going to have to do to sell? Right? Now, I knowing what I know now, if I went back to 2016, I promise you there is no way we could have gleaned the information and worked back from the commercials, because the space has been changing, the environment's been changing so much. Okay, we might have, polymer test lab, and David Walsh comments on this, not one engineer mentioned mixed melt flows as a problem. And it is the biggest problem for mechanical recycling, is making sure it aligns with the manufacturing process. So I don't know if that was an oversight or everybody was just so focused on the big problem. At the time, the big problem seemed, how are we going to sort all this?
Yeah.
I said at the start, I was working to some commercial assumptions. Well, that was very inside out thinking. Oh yeah, the biggest problem is purity. We need to be able to sort for any of this to work. And that is right. But there's another glaring problem, which is access to the market.
Yeah. And an understanding of what it takes at all different levels of that value chain in order to meet the demands of all of those different participants.
Absolutely. Yeah. And actually, all the conversations that we've had, since that point wouldn't have happened if we didn't have, the ability to deliver 100 tons that month with the customer. Yeah. It's only getting into that relationship with the customer that I know, or that we as an organization know what we know now.
Yeah. Yes. And so, that little bit of, that success that you've had, now you're able to produce at these kinds of volumes. Suddenly you're able to capture so much more from the customer because a certain level of trust has been established.
Well, that's it. Yeah. I mean, I don't mean to have a prop. It genuinely is just sat next here, but this waste bin here is my life achievement. It sounds silly. All right. Up to previously I'd be going around the shops and I'd see a watering can in a garden center and be like, that's my life achievement to my family. And they're like, what? What are you talking about? But honestly, to make a watering can, it's difficult. It's extrusion blow molding. And you know how many technologies had to be invented to get 100% waste into that application and change the color. But this one is a good story, interesting story. So that's actually won the Sustainable Product of the Year. We partnered with Mauser for it. So Mauser basically supply 50% of the NHS's sharps boxes. One of our facilities, after doing rigids, we moved into post NHS waste, so medical polymers. We've also moved into flexibles. So there's a bit of piece about how we adapted the technology for different feedstocks in the space. But one of the things we could do is take NHS polymers and put it back into NHS products. And that was a huge thing for the customer. But it has taken 2.5 years. We had the right price. We didn't quite have the right product, but everybody in that value chain wanted this to happen. And it's taken 2.5 years. And it's taken 2.5 years because of, I'd say, 6 months of technical work, but 2 years of change management work, organizational change. Not just organizational change, but changing the customer. We had to get the NHS to agree that we shouldn't actually try and make the bins yellow because that's bad for the environment. Instead, we should put a yellow label on it. And it's all melted into the polymer, so it's all integrated. So now we're kind of into marketeering as well. And this is big, and I suppose another big lesson of mine is I was the upscale engineer, then I was the ops manager, then I was the maintenance guy, then I was specifying a project. Now I'm doing sales. I'm not doing sales into an established market. I'm going to identify customer segments that we should target. Like what you do as a startup leader is whatever it takes. So I had to, didn't really have many staff before the engineering staff, I should say, before the investment. But after we got an investment, I had a budget for one engineer. And my brother had finished university, right? So I'm thinking, well, this is great. You know how to drive a tractor. So, your skills are broad enough to work at this site where it's very hands-on. And he had a degree in chemical engineering. And he did say to me, and to this day, he's the best recruiter in the company. He did say to me, all my friends who've done very well at university have had their placements dropped by oil and gas majors, whereas Exxon, Shell, BP, it was COVID. What are you going to do? And he said, you'd really be missing an opportunity if you missed out on ABC. Give me some names. So I asked him, do you think you could bring them in? And, so I had a budget for one engineer and came in the next day with 4 engineers. And I got in so much trouble. But in hindsight, I have to say, David Walsh, CEO, was kind of on board, actually. It was more the financial team were like, what are you doing? And we all, it was COVID as well, so we all sort of stayed in the company house that I'd rented near the factory. It was very intense, very close, all that fun stuff. But the reason I brought this up is I've been then free to move on to whatever the business needs, because I've had people who've been on the journey with me from the moment we actually, we were actually really starting to make progress. So a lot of the days where you would lose people, in the machine every night, cleaning it out, that sort of stuff, that had sort of gone. We brought in the engineers and they were sort of picking up where I'd left off and allowing me to go on to the next thing. And you've got to push all this stuff down. And you've got to have a cross-functional dynamic team. Levers, not gophers, if you know what I mean.
Yeah.
It takes longer initially. I wanted to be able to articulate what we're trying to do and let the smart boys and girls deal with it in their way and not micromanage too much. It's absolutely, it's completely necessary. If everything went through me, we'd be nowhere. Yeah. Absolutely nowhere. And
have you had any experience with management up until this point?
Not really. I mean, schools and universities, sports teams, always was in sort of leadership type roles. And actually, do you know what really helped? And it's probably no help to your listeners because it's such a unique set of circumstances. And it was very opportunistic. But they're all my brother's age. So it was very easy to adopt, how I interact with my younger brother at that time.
Use that as a model now, and just manage them the way you would manage your brother, basically.
Exactly. It was very friendly, very flat, very fun. Very good fun.
Yep.
Like, has to be. Guys were getting exposed to experiences that you wouldn't normally in the first 5 years of your career. But that's been the gig. Like, we couldn't afford to pay them very much at the start. Oil and gas was paying a lot more. And I suppose that's true for any industry, but other industries as well were paying a lot more. But they got experience in their teeth into things. And I told them, you can become indispensable. And right enough, they've sort of, over the years, filtered into the three kinds of engineers that we have in impact recycling. We've got project-driven engineers who are understanding the commercials and the technicals and understanding why we need to do a project. And that includes stakeholder management and everything like that. So they're really good at that. Operations engineers, they're running the process. What's happening day to day? Is this the right material? Why is that machine broken? And then design engineers. James, you never drew anything. How did you get this stuff built in the first instance? Well, mum and pop shop worked off of chalk on the floor. And that's genuinely how we upskilled the first boss. I had my design equations and everything on a piece of paper. The guy couldn't, that wasn't his language. He needed it drawn on the back of an envelope and then on the floor in the factory to scale.
Yeah.
So we didn't have cut lists or anything like that. And some of the engineers have come in, and at the time I was a bit allergic to the idea of somebody just sitting and drawing. But we're really now getting the benefit of all these 3D models and everything.
Yes.
And that's come from within the team. That's not top down. So it works both ways. You bring it, like, it's a luxury to say just hire the smartest people. But you cannot train enthusiasm and intuition. No. So I just hired some really enthusiastic people who are willing to move down from wherever they were into Newcastle, into a job in an industry they didn't want to work in for less money because it was COVID. But as part of that, they realized, I can be my own person here and drive the business on. And you know what? Just even having that initial team set a mold so that when we brought other people in, it kind of becomes self-perpetuating. I think that, on this journey, the way the first engineers or technical team are incubated is really, really important. One of the things they didn't get a choice on is whether we were introspective and almost R&D or commercial, because they came into a business that was running on a treadmill that was going faster than we could run. And David Walsh's job as CEO was to keep extending the length of that treadmill.
Yep.
Until we could keep up. And
when did they come in? When did they come in, James?
2019. Yeah.
Okay. So you had been through some of the really sticky points. You had been through some of the sticky points. And now things were stabilizing. You'd had some money in, and now you bring the guys in way more than anyone expected. But then there's a little bit of stability there, more than there had been. and other things
Yeah.
had been figured out.
Absolutely, but I still had a budget for one engineer and we had four. So I was very honest with them. I was like, well, one of the guys, Gregor, I told him, like, you're coming in, but you need to get this project with me. Otherwise, I don't know what we're like. This is just a COVID work experience for you then. Otherwise, and he was straight into the grant to develop our boss project, our boss technology for the rigid process, which was established, and then take that and apply it to the NHS polymers, which is what we do here in Bellshill, where I am at the moment in Glasgow. And we won that grant. So actually, he was recounting his first day at work. So he'd come down, checked out the factory. Most of the engineers as part of the journey just got put straight onto tools and to run the factory as operators to learn whether the process made sense and whether anything we're doing makes sense. Like, think about what we're doing. But Gregor, his first day was to go straight to a key stakeholder site and evaluate their process straight out of university. And actually, he was telling me that story back the other day, and I was like, I'd never do that today. But I was like, but he did tell me, he's like, you were very straight with me. He's like, this is how it's got to work. Otherwise, it's not going to work. Like, you guys are on a fast path. And he was. So he managed that meeting well. And it, from that, we won maybe £80,000, which covered his salary and the upscale of the new prototype for the medical process. And off the back of that grant, we actually won a £3 million grant from Innovate UK to build an entire prototype process here at Bellshill. And Gregor was part of every single part of that, including pitching to Innovate UK, including bringing in the stakeholders. So Gregor's very much a project engineer. He understands the landscape. He understands technicals. He's never actually run the factory a day in his life. That's an ongoing joke because every other engineer has had to go through that pain. But he just came in at the right place, right time. And then, there's so many stories like that where by bringing someone in who's slightly overqualified for the initial remit, you get so much out of them with the spare RAM, as it were, or the spare hours.
Yeah. You've hit
the
on
£3
a
million
couple of things.
Factory. Oh yeah, go ahead, Seth.
No, sorry. You've hit on a couple of things that are just so interesting. I think I do wonder if the number, instead of bringing one, you brought four. And so suddenly now, did all four know each other when they came in?
There was a little bit of that. They knew, look, Scotland's a small country and
sure,
university. Yeah. So I think they all knew of each other some way.
Okay.
Yeah. So I suppose a common denominator is they all knew of my brother either first.
They all knew
second,
of your
third.
brother. Yeah. But you're not just hiring one and then it feels like your job, but you hire four. The circumstances aren't great, but equally they're going to get exposed to a ton of stuff that they wouldn't have a hope of getting exposed to in different roles. And it almost starts to feel like a bit of a band at that point.
Definitely.
Not a rock band, but like a band of brothers. We're here, we're taking on this challenge. The conditions are shit, but we're going to somehow make it through. Let's see how far we can take this. It becomes fun.
Yeah, more chain gang than rock band, I'd say.
Yeah.
We were linked to each other, all right. And actually, at the time, I did think about whether I was doing the right thing, but I had this brilliant thing called COVID. So they were gonna, I was thinking
what
about
else
just
were they
my brother,
gonna do?
what are you gonna do? What else are you gonna do? You're gonna get some great work experience. And you know what? I told them at the start, I was like, in 6 months, some of you might decide you'll hate this. It might be a year and a half. You get the offer you want, and you go. And I was like, I'm okay with that. Like, this is about giving you guys experience and me getting as much out of it as possible. And they've all stayed.
Has that culture been maintained?
I think so, yeah. Well, we've now got a team of 12 engineers. We employ 84 people. So within the engineering team, it's still absolutely flat and absolutely outside in. And whilst we are scaling up as a business, our environment is not one where we're scaling up. Scaling up, if you define it properly, is increasing your market share whilst increasing your production capabilities simultaneously. And we're not doing that. We build a factory, then we get the sales, or we get the sales and we build the factory. We're very much at nail it phase. We're still nailing it. So our supply chain is not scaling up yet. It's still figuring it out. it doesn't work for all stakeholders at the same time yet. So we're still completely flat, even though we are scaling up and doing very large projects now.
Yeah.
Now, has that been operations is its own thing? So you need that sort of command and control sometimes. But actually, the more I understand about what we're doing, the more we're sort of pushing that flat structure out across the rest of the organization as well. Because somebody ran an established operation in a, let's say, sail-it industry, one that's been well established, doesn't mean that they have the same tools, I suppose, to create from scratch new processes. They can run them once they've been defined, but doesn't mean that they can establish it from the start. And really, I think in terms of innovating, it's not just technology. There's so much about how humans interface, how the sales process interfaces. Like, the more I understand about what we've done, the more I realize how you set that culture can either hold you back or help you get on. And I think the flat, manage with your eyes structure and listen to what everybody says is the one that's gonna get you through.
Do you think that's stage specific? Do you think that's stage specific? In other words, does this apply right now? But when you are 2 or 3 times the size, you might need something else.
I do think it's stage specific, but your stage must be guided by your environment. So simple stages: nail it, you're figuring it out; scale it, you're scaling it up; sail it. Well, this as an organization, you could be scaling it or sailing it, but your environment might be such that it's so dynamic. It kind of has more say in what stage you're in. And I think that's my lesson from Impact is everything we wrote down is kind of moot within 6 months anyway, or it's not relevant is what I'm trying to say. And by fostering such an eyes up culture, eyes, ears up culture, we've been able to adapt and respond to what the market's doing. And my favorite example, and the way I convince our team and others, and it's stolen from Professor Bill Fisher at MIT, so I'll credit to him, but he says, Scott versus Amundsen, who goes to the South Pole first, right? So it's an unknown environment, but Scott had all the funding, brand new ship. He had a ship's cook, he had an accountant, he had a meteorologist. He brought best in class or best practices from British military as to how you do expeditions. So very strict, very command and control, but still very siloed and very specific specialists. A ship, I think it was nearly 100 people on that ship. Amundsen, in terms of preparing for his trip, went and lived at the North Pole for a while. It was the closest analog he had to where he was going. So he was thinking about the environment, not what he was doing. And he decided, and he lived with Inuits, and he decided at the end to go with 3 people he knew very well, who were just generalists, just generally good at whatever they tried their hand to. You've got Amundsen and his 3 mates, and then you've got a ship of 100 bringing the best that the British technology and expeditionary forces had in terms of organizational structure. And what happened? Well, Amundsen got there 3 weeks early. He deliberated caching food, but he thought that would be rude, a bit of a "we beat you here," sort of thing. So he didn't decide to cache food out of respect and got back, and they all survived. Scott, within 2 weeks, half of them were gone. They did actually make it to the South Pole, but they'd ran out of food. So shame that there was no cache food. And they all ultimately died.
Yeah.
Which, if you bring a scale it structure or a sail it structure to a nail it environment, you're going to get eaten alive. The other phrase I like is, people trying to put all these business processes on top of a dynamic process. You're basically pouring cement over a process once you start applying these rigorous ERP systems or anything like that. You've got to be eyes up. Yeah, when you're starting up, it's really important.
I love that expression, eyes up. What other things do you see, as far as other engineering teams, other technology development teams do that you think they shouldn't be doing, things that frustrate you, based on your experience, based on your observations? What things do too many engineering teams do that they shouldn't be doing?
Yeah, get to the next stepping stone. So as technical guys and girls, it can be very appealing to focus on the problem, technical problem. But actually, if it's not stopping you from getting to the next commercial stepping stone, you should be focusing on the things you need to do that allow you to get to that stepping stone. Because the problem's going to be there. And actually, some problems go away with scale, and ones you never thought of come up. Like, so let's say you're a TRL4 and you've got a problem and it's quite specific and you're, I don't know, trying to solve it. And you could spend all your time doing that. But actually, if you could see all your timelines at any one point, you might see at TRL8, there's this really big problem. And actually getting there first and knowing that that's a problem gives you such a competitive advantage over all of your competitors that actually it was the most beneficial thing you ever did was getting to the big problem. So just keep like, never assume that there's one problem, right? When you're scaling up, and scale invariance, like that's the other thing. So, it kind of comes down to the same thing. Like sometimes things you do at a small scale just do not translate. Everything you learn at a small scale might not translate at a big scale. Yeah, and that's true for everything from testing through to how things operate. Actually, a lot on testing. Actually, sometimes it's very easy to do a lot of testing on things that are statistically irrelevant. I've seen that a lot in the polymer world. So, somebody's trying to evaluate whether a polymer will work in a process, so they'll do a DSC, which is a thermal analysis to work out. Well, it's actually qualitative, it's not quantitative, but they'll try and establish the ratio of ethylene to propylene, for instance. But never think about the fact that they're taking a 12 milligram sample and applying it to a 20-ton load in a population that's neither well distributed nor homogeneous. It's like, do the statistical analysis. You need to do 780 of them, and they take an hour each for you to even have a 90% confidence and a 90% accuracy. So again, that's, I suppose, an example of me borrowing established maths and applying it to our problem. So everybody, thankfully, America and the UK are bi-party, more or less. You're going to vote A or B. But what a lot of people do is walk into a pub and ask the room who you're going to vote for and then apply it to the whole population. That's what's happening in polymer testing sometimes. You've got to come up with more creative, more robust ways. And the final thing, you said 3 things, so I do have another one, and it's something that I wear with pride. When people came to our machine, Boss, they are really, oh, it's so robust, or it's so simple. That's the best compliment you can ever get. So there's a lot of complicated things happening in Boss, and I spent the best part of a year trying to work out how to turn, well, we used a linear actuator at lab scale, and to build up to full scale, the thing the linear actuator was going to have to lift weighed about 500 kilos before you added all the water and the polymer. So it just wasn't going to work like that. So I spent a year trying to figure out how to make up and down motion. And there was lots of ways of doing it, from, pneumatics. Like, we knew lots of ways of doing it. But I quite rightly spent a lot of time or as a team, we spent a lot of time thinking about how to do that. And then realized, driving the car home, oh my God, up and down to round and round in a car. Well, a motor's round and round, and I just need up and down. So it's basically a piston, cam, wheel backwards. It's the only moving part in the system. And again, everything else, like the outlet gates and everything, people were wanting, pneumatically operated gates and lasers and everything like that. And I was like, no, we're doing a weir. It's 200 years old. It worked. There's canals in Holland that have had weirs that are, 250, 300 years old, and they still work. So like, when you're trying to do something new, bring everything back as old as possible, whether it's the upscale maths, whether it's, all the widgets that you don't need. Like, the core technology is what we're trying to get right. Everything around the material handling can, design, like the tanks and how you flow things, all of that, go as old school as possible, particularly for a prototype. I think simplicity is the ultimate sophistication. Like,
I love that.
And you know what? We've never changed. Yeah, it's one of our favorites.
That's great.
Yeah.
James, I have loved this. I have freaking loved this. Thank you so, so much for joining me today. This has been a delight. I have learned a ton, and I'm sure our listeners will love this. So thank you.
Well, thank you so much, Chris. Thank you for having me.
You've been listening to the Lab to Market Leadership Podcast, brought to you by Deep Tech Leaders. This podcast has been produced by Bauhaus. You can find out more about us on LinkedIn, Spotify, Apple, or wherever you get your podcasts.